Last class we done about the oxo acids of phosphorus, okay, and PCl5, PCl5, PCl3, etc. Their preparation and we done, okay. So that's all about which family, nitrogen family. Today is oxygen family and it is which one? Group 16, okay. Oxygen family group 16 and it is also known as what? Chalcogens, okay. Some of them they will pronounce it as chalcogens, anyway you can pronounce, okay. And what are the members of oxygen family? Oxygen family mainly consists of oxygen, sulfur, selenium, tellurium and polonium. Okay. So oxygen O, sulfur S, selenium Se, tellurium Te and PO means which one? Polonium. Okay. And oxygen, how the abundance and all, how it is present in atmosphere, air, etc. Oxygen is the most abundant element in the earth crust, okay, and it is coming around 46.6%. Yes. Then if you are checking in atmosphere, it is the second most abundant element in the atmosphere. Nitrogen is the first abundant element and oxygen is the second most abundant element in the atmosphere and it is coming around 20.946%. Okay. Then sulfur is the 16th abundant element in the earth crust and it is coming 0.03, 0.2, 0.1%. And sulfur is existing as sulfate and sulfides. For example, it is existing as calcium sulfate dot 2H2O. It is known as gypsum. Then MgSO4.7H2O. It is known as what? Epsom salt. Okay. Then barium is existing as barium. As barium sulfate also it is existing. That is barite. Then lead sulfide. It is known as galena. Then zinc sulfide. It is known as zinc blende. Then copper pyrites. What is the formula? CuFeS2. So sulfur is existing as mainly sulfates and sulfides. Next, if you are coming to selenium and tellurium, they are also existing as sulfides. Okay, and sulfides means, for example, selenides and tellurides. It is equation formula is not given, it is not required. Okay, then polonium is produced as the decay product of thorium and uranium. That means if the thorium and uranium, if it is undergoing nuclear fission, polonium is produced. Okay. So next, if you are moving to the general properties of this group, oxygen family. Okay, first we will note down their electronic configuration. Okay, so generally they will have 6 valence electrons. That means 6 electrons in the outermost shell and having the electronic configuration ns2 np6. Outer electronic configuration is which one? ns2 np4, not 6. ns2 np4 and n is which period it belong to, that will, the n will use that number. Okay, so ns2 np4. So outer electronic, on how many valence electrons are there in this? 6 valence electrons are there. Okay, so if you are checking oxygen number is having atomic number 8. And how we can write the electronic configuration of it is helium. We know first we will write the noble gas, then easy to write, otherwise we have to write from -2 to S2 like that. Okay, so oxygen is 8. We know helium plus 2s2 2p4. Helium 2s2 2p4. So helium already 2 is there. Then 2 plus 2 4 plus 4 8 it will come. Okay, why it is 2? Because it in which period it is coming? It is coming in the second period. Okay. Then sulfur. Sulfur is having atomic number 16 and it is neon. Neon is having 10. Okay. So 10 plus 2 plus 4 means 16 we will get. And it is outer electronic configuration is 3s2 3p4. Okay. And 3, why it is 3? Because it is belong to which period? Third period. Okay. Then next is selenium. Selenium means it is having atomic number 34 and its electronic configuration is argon D10, 3D10, 4s2 4p4 and the fourth period, it is coming in which period? Fourth period. Next is tellurium. Tellurium is having atomic number 52 and it is the electronic configuration is krypton 4d10 5s2 5p4. Okay, and these two, this one 5 means what? It is belong to fifth period. Next one is polonium. Polonium is having atomic number 84, so its electronic configuration is H6 xenon 4f14 5d10 6s2 6p4. If you are checking This is in 6th period, and if you are checking, all these elements are having valence electron. How much it is? 6 valence electrons. Okay, and the last electron is going to which subshell? P shell. That is why it is known as p orbital, and the 6 valence electrons are having with the general electronic configuration, which one? ns2 np4. Okay, so next we are moving to the atomic and ionic radii. Atomic and ionic radii. We know atomic and ionic radii, how it is in the group. Okay, in the group, if you are checking, oxygen, sulfur, selenium, tellurium and polonium, it is the members. Okay, so atomic and ionic radii, if you are moving down the group, generally what will happen? It will increases, because what is that? Atomic number increases, more shells are added. That is why what is happening? Atomic and ionic radii increases. Then second thing, if I am taking, is ionization energy, IE. All these things are common. Okay, ionization energy, we know if you are moving down the group, what will happen? Size increases. So it is very easy to remove the outermost electron. Okay, so that is why ionization energy decreases down the group. It is common tendency. Ionization energy decreases down the group. But if you are comparing group 15, that is group 15 means what? Which family? Nitrogen family. And group 16, our oxygen family. Okay, we know if you are moving from left nitrogen family, then oxygen family it will come, right? Okay, so from left to right it is going. So how is the tendency? If you are moving from left to right, ionization energy increases along the period because size is decreasing. Okay, but if you are checking group 15, it is having higher ionization energy compared to group 16. Usually group 16 will have higher, but group 15 is having higher ionization energy than group 16, because if you are checking what was the outer electronic configuration for group 15 nitrogen family, it was ns2 np3. So p is which one? Half filled. So p orbital is half filled. That is why it is having an extra stability. So group 15 elements are having higher ionization energy compared to which one? Group 16. Down the group it is decreases. Ionization energy decreases. Okay. Next property, if you are checking, electron gain enthalpy. Electron gain enthalpy. Electron gain enthalpy means, we know these oxygen families having general electron configuration ns2 np4. That means 6 electrons are there. So 2 more electrons it is needed to complete the octet or to become stable. So these elements always have a tendency to attract 2 more electrons. Okay, so that is why they are having high negative electron gain enthalpy. Okay, so they will have a high negative electron gain enthalpy, and electron gain enthalpy decreases down the group due to what? Increasing atomic size. Electron gain enthalpy decreases down the group due to what? Increasing atomic size. Okay, next property is coming, electronegativity. Electronegativity, we know fluorine, it is a halogen. It is the most electronegative element in the periodic table. Okay, so they are having high electronegativity value next to which one? Halogens. First it is coming halogens, then oxygen, then fluorine family. No, so it is having high electronegativity, then oxygen family is having high electronegativity next to which one? Fluorine family. Okay, and the electronegativity value also decreases down the group, decreases down the group due to increasing which one? Atomic size. So that is the general properties, general characteristics of which family? Oxygen family. First it was electronic configuration, then which one? Atomic and ionic radii, then which one? Ionization energy, then electron gain enthalpy, then electronegativity. So that is the general properties. So clear all of you about the general properties? Next is the physical properties of this family. So if you are checking the physical properties, melting point and boiling point increases with increasing the atomic number. And there is a large difference between the melting point and boiling point of oxygen and sulfur. Okay. Why it is means oxygen? Because of their atomicity. Atomicity means oxygen is existing as only 2. O2, okay, but sulfur is existing as what? S8. So in one sulfur it is S8 molecules are there. S8 sulfur, S atom, 8 atoms are there in a sulfur molecule. So we have to supply more temperature. Okay, so that is why there is a large difference between the boiling point and melting point of sulfur and oxygen. Okay, then then if you are moving down, polonium is having low, usually it is increases down the group, melting point and boiling point, but if you are checking, polonium is having low boiling point and melting point. It is due to inert pair effect. Inert pair effect means we know the s electrons are the valence electrons. The tendency of the s electrons do not undergo any type of reaction or inactive. I already explained previous one class what is inert pair effect. Okay, so polonium is having low melting point and boiling point due to inert pair effect. Okay, then if you are moving to the metallic character, they are having less metallic character due to high ionization energy. And if you are checking, oxygen and sulfur is non-metal. We know oxygen is a gas, okay, and selenium and tellurium is metalloid. Metalloid means it will have the characteristics of semiconductors. Then polonium is radioactive. They can ask one more question like that. In which one? P block. Which one is radioactive? So polonium is a radioactive element. Okay. Then all of these members exhibit which one? Allotropy. Allotropy means what? Existing in different forms. Okay. So like sulfur, we know phosphorus, black phosphorus, white phosphorus, it was there like that. All members can exhibit in which form? Allotropy, different forms. Okay. So that is just about the physical properties. Then if you are moving to the oxidation states, okay, oxidation state, this is written here, the oxidation state. Oxygen is having common, it is having -2 oxidation state, except in which one? OF2. That is, in this case oxygen is having +2 oxidation state. Then O2F2, in this case oxygen is having +1 oxidation state, and hydrogen peroxide it is -1. They can ask here also, you can expect one more question like in which compound oxygen is having -1 oxidation state, or they will give this compound and in this what is the oxidation state of oxygen. So generally oxygen is having -2 oxidation state except in OF2, O2F2 and H2O2. Okay. Then oxygen does not have +6 oxidation state. Which oxidation state? +6 oxidation state. What is the reason? Is due to the absence of vacant d orbital, or due to the non-availability of d orbital. Oxygen is not having +6 oxidation state. Then sulfur is having -2, +2, +4, +6. Okay. Then selenium is having -2, +2, +4 and +6. So if you are checking, these all are having which one? +6. Tellurium is having 2, 2, 4, 6. -2, 2, 4, 6. Polonium is having 2, 4. So polonium is also not having which one? Polonium is also not having +6 oxidation state due to, what is the reason? Inert pair effect. Polonium is having lower melting point and boiling point also due to which one? Inert pair effect, and it is not having +6 oxidation state due to inert pair effect. Okay, so that is about which one? The oxidation states of this family. Next is the anomalous properties of oxygen. Just like nitrogen, it is very important. They will ask what is the reason for the anomalous behavior or anomalous properties of oxygen. Okay, so what is the same reason like nitrogen? It's very easy to get 3 mark. Okay, small size, high electronegativity, high ionization energy, absence of d orbital in valence shell. So why oxygen is showing difference or anomalous properties from other members of the family is due to small in size, its high electronegativity and its high ionization energy, and absence of d orbital in the valence shell. Okay, any 3 reasons they will ask. Next, what are the difference? That also you can expect. Write 3 difference between oxygen and other members of the family. First one is elemental state. Elemental state means oxygen is existing as O2, it is diatomic, but all other members are existing as octatomic. Okay. Then oxidation state, just now we saw it is having maximum -2, -1, +1 and +2. There is no oxidation state more than +2. Okay, due to the absence of d orbital. Okay. Then hydrogen bonding, we know oxygen is electronegative. Okay, so it can form hydrogen bonding with hydrogen. So that is why it is existing as liquid, but if you are taking hydrogen sulfide, hydrogen H is hydrogen selenium, it is existing as gas molecule. Then it's having the maximum covalency or maximum oxidation state, we saw it is +2, okay, but others are having +6 because oxygen is not having d orbitals. Then compounds, its oxygens and its compounds of oxygen are polar and ionic due to its high electronegativity. Then we know last year oxygen is paramagnetic due to the presence of unpaired electrons, okay. So oxygen is paramagnetic, but others are not paramagnetic. That means others are diamagnetic. So any easy three differences you can learn. So that is about the oxygen and the difference, anomalous properties of oxygen and differences. Next we are moving to the chemical properties of oxygen family. First is reaction with hydrogen. Okay. So with the hydrogen it is forming a hydrides type general formula H2E. Okay. And E equal to oxygen, sulfur, selenium, tellurium, polonium. For example, H2O, H2S, H2Se. So generally they form a hydride having a formula H2E. E means our oxygen family. Okay. So what are the properties of these hydrides? First property is acidic character. Acidic character, this is the order of the hydrides. How the acidic character of the hydrides? H2O is less having acidity. Then it is increasing if you are moving down the group. That is H2TE is having highest acidic character in case of hydrides. What is the reason is if you are moving down, atomic size increases. Atomic size increases means what? The bond length. Which bond? Hydrogen element bond. That is He, hydrogen element bond. For example, here HO, H2O is there. So one more hydrogen is here. We can draw like this simply. Okay, so this H or A bond, that means hydrogen and elements of oxygen family. For example, He bond length increases. Size increases means bond length increases. Then it is easy to break the bond. So bond dissociation enthalpy is very less. Okay, very less amount of energy you have to supply to break the bond. With increasing the atomic number, bond length increases. So very less bond dissociation enthalpy. So it is very easy to break the bond and very easy to remove the hydrogen atoms. Okay. So any acidic substance which is donating proton easily, that will be more acidic. So if you are comparing here, H2T is having highest which one acidity due to increasing which one bond length. Okay. And due to increasing bond length, what will be less? Bond dissociation enthalpy will be less. Then thermal stability of hydrides. This is the order H2O, H2S, H2. That means if you are moving down the group, that is H2P or polonium or H2T is having lowest thermal stability. What is the reason? Same reason. If you are moving down the group, what is happening? The bond length increases. So bond dissociation enthalpy will be very less. We have to supply very less amount energy to break the. So thermal stability also, this is the order. Okay, so down the group, the hydrides, how it is, the thermal stability decreases, but acidity increases down the group. Okay, then reducing property. All hydrides of these families reduce good, showing good reducing characters, but except water. Okay, so the order is same thing. H2O is the weakest reducing agent. Then H2SC, H2TE and H2P is the highest or strongest reducing agent due to the same reason. Which reason we can say? Due to increasing the atomic size, what will happen? Bond length increases and bond dissociation enthalpy decreases. Okay. Then boiling point and volatility. Volatility is vapor, tendency to convert into a vapor. Okay. Boiling point, hydrogen H2O among the hydrides of water, H2O is having the highest boiling point due to which one? Hydrogen bonding. I already told you oxygen is having the tendency to form hydrogen bonding. So it is having highest boiling point among the hydrides. Then if you are moving down, H2S, H2O and from H2S to H2S, there is a sudden drop, decreasing boiling point. Okay. Then if you are moving from H2S to H2TE, there is increasing boiling point due to increasing atomic size and increasing the which one? Van der Waals force of attraction. So that is, these are the main properties of which one? Hydrides. Then reactivity towards oxygen. Okay. When these family members react with oxygen, what will happen? Okay, they will form oxides. Reaction with the oxygen means what will happen? Oxides only formed. Okay, so generally, which one? Oxygen of the type monoxide, that is EO, for example SO, sulfur oxygen, except selenium. Selenium is not forming the monoxide. Okay, then trioxide means dioxide, EO2, that is example SO2. Then trioxide, EO3 type, example SO3. Okay, so generally if you are taking, they will form three types of oxides. Monoxide having the general formula EO, except which one? Selenium. Then dioxide having the general formula EO2. Okay, and trioxide having the general formula EO3. So if you are checking, sulfur is having monoxide, dioxide and trioxide. Okay, tellurium is having dioxide and trioxide, and selenium is having dioxide and trioxide. Polonium is also having, what is that, dioxide and trioxide. So that is reactivity towards the hydrogen and reactivity towards which one? Oxygen. See these properties of hydrides. They can ask which one is more acidic, which one is more having high thermal stability, what is the reason, and all they can ask. Okay, and if you are one point I forgot to tell you, among these oxides, okay, acidity and all, it is what? Decreasing down the group. Then sulfur dioxide is a gas, but SiO2 is not a gas. Okay, why sulfur dioxide is existing as gas? Means it is existing as single sulfur dioxide molecule. Okay, but if you are checking SiO2, it is not a gas, because SiO2 is existing as a large polymeric structure. Okay, so it is not easy to break the bonds. Okay, so sulfur dioxide is a gas molecule, but SiO2 is not a gas. So that is the chemical properties, including what is a reaction towards the hydrogen and reaction towards the oxygen. The chemical property is reaction towards halogens. First it was reaction towards hydrogen, next reaction towards oxygen, then next is reaction towards halogens. Okay, so in this case generally they are forming three types of halides, that is EX2 type, that is dihalide. Here E equal to our oxygen, sulfur, our family members, that is oxygen, sulfur, selenium, tellurium, etc. X means generally we know, usually we know X equal to halogen, fluorine, chlorine, bromine, etc. Okay, then EX4 tetrahalides. Okay, then EX6 hexahalide. And if one thing it is there in OF2. OF2 means here if you are taking in writing this type of compounds, electronegative, more electronegative element should write the right side, and this is less will be here. So comparing oxygen, fluorine is having high electronegativity. So this compound is named as oxygen fluoride, because it is having, fluorine is having high electronegativity. But if you are taking other compounds like chlorine, oxygen, ClO2, it is a compound. In this case, oxygen is having high electronegativity. That is why oxygen we wrote it right side. Okay, and these compounds name other compounds other than fluorine, because they are having less electronegativity compared to fluorine. So we can write like this, and their compounds are known as oxides. Here it is which one? Fluoride, because it is which one? Because it is fluorine is electronegative than oxide. But here chlorine, oxygen is electronegative than chlorine. So what is the name of this compound? Is chlorine dioxide. What is that? Chlorine dioxide. It is coming. The next is halogen family is coming. We will now detailed studies there. So here it is ending with fluoride. But here if you are taking other compounds other than fluorine, if any halogens are there, means they will end with which one? Oxides. Okay, so what is it? It will be oxide, means it is chloride monoxide, chloride dioxide we can name it as. So end with oxide. Okay, then next if we are moving to the properties of halides, their thermal stability, their stability order, not thermal stability order will be fluoride compounds, halides are, fluoride are having more stability than chlorides, then bromides, then iodides. Okay, then next is among halides, only hexafluorides are stable, not hexachloride, not hexabromide, only hexafluorides are stable. Okay, then hexafluorides are gaseous and they are having octahedral structure, except which one? SF6. Its structure is coming in detail. All others are having hexafluorides, are having all other hexafluorides having are gaseous and octahedral except which one? SF6, sulfur hexafluoride. Then if you are coming to tetrahalides, for example SF4 is a gas, but SCF4 is a liquid and TF4 is a solid. And they are having hybridization. Tetrahalides are having sp3 dehybridization with trigonal bipyramidal structure. Then dihalides, except selenium, all other members forming dichlorides and dibromide. Dichlorides and dibromide except which one? Selenium. Okay. And they are having, dihalides are having sp3 hybridization with tetrahedral structure. Okay. Then we know monohalides are not forming. If the monohalides are there means generally they will exist as dimer. For example, SF we will expect, but it will not exist as SF. It will be S2F2 or S2Cl2 dimer. Dimer means combination of two molecules, Sc2Cl2. And if that dimer is there means that dimer itself undergo decomposition to form corresponding some compounds. So that is why monooxides are not existing. Here we can monohalides are not existing. Here we can see Sc2Cl2. It will undergo decomposition or it will be undergo decomposition. It will form SeCl4 plus selenium. So generally monohalides are not exist. Okay, only dihalide, tetrahalide and hexahalides are there. Hexahalides in that SF fluoride compounds, that is fluoride, hexafluoride compounds are very stable. Okay, and generally these hexahalides are having which structure? Octahedral structure, but the tetrahalides are having sp3 dehybridization with the trigonal bipyramidal structure. And our dihalides, okay, they are having sp3 hybridization with the tetrahedral structure. Okay, so that is about the general properties, physical, chemical properties of which family? Our oxygen family. And in this part it is not very much important part is not there. Only you have to know hydrides of this family, acidic character, how it is increasing, boiling order, that increasing and decreasing order, and you have to know what is the reason. That much is enough in this part. Okay, so clear all of you. That is about today's topic.